Okay, so good day everyone. So we are now in the rational numbers, real numbers, and algebra. The Pythagoreans and irrational numbers. Pythagoras, circa 570 BCE, was one of the most famous of all Greek mathematicians. After his studies and travels, he founded a school in southern Italy. This school, an academy of philosophy, mathematics, and natural science, developed into a closely knight brotherhood with the secret rites and observances. The society was dispersed, but the brotherhood continued to exist for the least 2 centuries after the death of Pythagoras. The Pythagoreans and irrational number. Much of the work of Pythagoreans was done in whole numbers, but they also believed that all measurements could be done with fractions. However, the hypotenuse C, nakikita natin na figure dito sa right part, isa siyang right triangle dahil dito sa 90 degrees angle. Then, meron siyang given na sides, 1 unit dun sa kanyang leg. Then, yung another leg niya ay 1 unit at yung longest leg niya ay side C. However, the hypotenuse, side C of the right triangle where leg A and leg B is equals to 1 caused them some alarm. They could not find a fraction to measure C and still fit the Pythagorean theorem. We have the A squared plus B squared equals to C squared. One feeble attempt was to say that C is equals to 7/5. Then C squared is equals to 49/25 or almost 2. In this presentation, we have introduced number system much the same as they are developed in the school curriculum. The counting numbers came first. Diba? Ito yung atin inintroduce muna yung counting numbers. Then 0 was included to form the whole numbers. Siyempre, pag dinagdagan natin ng 0 itong counting numbers, makukonect na ito with the whole numbers. Because of the need to deal with the parts of a whole, fractions were introduced. At kapag in-extend pa natin itong whole numbers, then mapupunta tayo sa tinatawag natin fractions. Ganun din sa integers. Since there was a need to have numbers to represent almost less than 0, the set of integers was introduced. The relationships among these sets are illustrated in the figure 9.1, where each arrow represent is a subset of, ibig sabihin itong arrow, itong counting numbers ay pwede natin sabihin na subset of whole number. Ibig sabihin, ang ginagamit natin na symbol for counting numbers ay letter N. So letter N, set of counting numbers, is a subset of whole numbers. At yung ginagamit natin na letter for whole numbers ay W, represent for the set of whole numbers. Then, ang whole numbers pwede siya mag-subdivide or ibig sabihin, ang whole numbers pwedeng maging subset ng fractions. Ang whole numbers din ay pwedeng maging subset ng integers. Okay. It is the objective of this chapter to introduce one final number system. First, the rational numbers, and then the real numbers. So, unahin muna natin itong rational numbers. Both of these are extension of our existing number system. The set of rational numbers is composed of the fractions and their opposites. And the real numbers include all of the rational numbers together with additional numbers such as pi and square root of 2. Finally, we use the real numbers to solve equation and inequalities, and we graph fractions. So, ito ngayon ang magiging whole concept or idea na tinatawag nating rational numbers. Mapapansin mo ang natural numbers ay yung set ng natural numbers belong doon sa set ng whole numbers. Then yung set ng whole numbers at set ng natural numbers ay belong doon sa ating tinatawag na integers numbers. Then ang integers, whole numbers at natural numbers ay belong naman doon sa tinatawag na rational numbers. Rational numbers, an extension of fraction and integers. There are many reasons for needing numbers that have both reciprocals, as fractions do, and opposites, as integers do. For example, the fraction 2/3 satisfies the equation of 3x equals 2. Diba? Kasi itong x dito represent as the unknown. Or, since ang given natin na x or unknown ay 2/3, so pwedeng maging 3 of 2/3, which is also the same as 2. And negative 3 satisfies the equation of x plus 3 equals 0. Since ang given natin na x is negative 3, so we have negative 3 plus 3 is equals to 0. However, there is neither a fraction nor an integer that satisfy the equation. For example, 3x equals negative 2. So to find such a number, we need the set of real numbers. Kasi mapapansin mo, di ba, ang fraction ay ginagamit lang natin sa positive numbers. At ang mga integers ay pwedeng gumamit ng negative numbers. Kapag pinagsama natin yon, negative numbers plus fraction, pwede na tayong gumamit ng another set of rational numbers. So by definition, our rational numbers, the set of rational numbers is the set of, we use symbol Q. Gamitin natin yung symbol na Q. So symbol of Q, it is defined as the set of A over B such that A and B are integers and B is not equal to 0. Then yung ating kaninang figure 9.1, di ba? Yung sabi doon ay counting numbers, subset of whole numbers. At yung whole numbers, pwedeng maging subset ng fraction, pwede naming maging subset ng integers. So pag pinagsama natin yung fraction and integers, then we're going through rational numbers. Okay? So finally, we can say that counting numbers, set of counting numbers is a subset of, natin. So counting numbers is a subset of whole numbers, and counting subset of whole numbers is a subset of rational numbers or yung ginagamit natin na Q. Okay? Ayan, ganyan. Okay, so ito yung mga example natin ng rational numbers. Sama-sama na yan. So meron tayong integers, meron tayong fractions. So pag pinagsama, pwedeng maka-encounter ng negative. At ang 0, gaya ng definition natin kanina, ang 0 is also called a rational number. Kasi we can express 0 as 0 over 1, 0 over 3, 0 over 5, and so on. So sa lahat ng yun, ang sagot pa rin nun ay 0. The equality of rational numbers. So as with fraction, each rational number has infinite number of representation. For example, 1/2, we can extend it into 2 over 4, or into 3 over 6, or into negative 1 over negative 2, or into negative 2 and negative 4, and so on. So the rational number 1/2 can be viewed as the idea represent all by all of its various representations. Similarly, the number negative 2/3 should be or should come to mind when any of the representation of negative 2 over 3 or 2 over negative 3 or negative 4 over 6 or 4 over negative 6 and so on. So by the theorem 9.1, let A over B be any rational number and N any non-zero integers. Then we have the A over B is equals to AN over BN is the same as NA over NB. So by using the definition of equality of rational numbers, it can be shown that the following theorem holds for a rational numbers. Okay, so ito yung mga example natin. Ibig sabihin, ang mga negative signs, kahit siya ay mapunta sa numerator, basta isa lang yung negative sign or sa denominator, the same din yan sa negative rational numbers. So, pwede nating sabihin na ang negative A over B is the same as A over negative B. A over negative B. At parehas din yan sa negative na nasa middle ng ating rational number. Negative A over B. Yan. So lahat ng yan ay negative rational numbers. So negative A over B is the same as A over negative B is also equals to negative A over B. Okay. Then kanina, so dinefine na rin natin yung addition of a rational number and so on. So parehas lang ito ng pag-operate sa integers. Okay, properties of rational numbers. We have rational number addition. Let A over B, comma, C over D, comma, and E over F be any rational number. So we have closure property for rational number addition. A over B plus C over D is a rational number. So also we have commutative property for rational number addition. A over B plus C over D is also the same as C over D plus A over B. Then we have also associative property for rational number addition. So the quantity of A over B plus C over D plus E over F is also equal to A over B plus the quantity of C over D plus E over F. Then also we have identity property for rational number addition. A over B plus 0 is the same or equal to A over B or equal to 0 plus A over B. 0 is represent as equal to 0 over M where M is not 0. Next, addition inverse property for rational number addition. For every rational number A over B, there exists a unique rational numbers negative A over B such that A over B plus the negative A over B is equal to 0. Also, negative of A over B plus A over B. So the properties for rational number multiplication. Let A over B, C over D, and E over F be a rational number. So we have also a closure property for rational number multiplication. A over B times C over D is equals to A over C over B of B times D is also a rational number. Therefore, it is close to rational number multiplication. Also, we have commutative property. A over B times C over D is the same or equal to C over D times A over B. Associative property, association of A over B times C over D times E over F is also equal to A over B times the association of C over D times E over F. Identity, ang identity property ng rational number multiplication ay 1 because A over B times 1 is A over B itself. And also true with 1 times A over B, where 1 is equal to M over M, where M is not 0. Then, ang multiplicative inverse naman ng rational number multiplication ay yung kanyang tinatawag natin na reciprocal. So for every non-zero rational number A over B, there exists a unique number A B over A such that A over B times B over A is equals to 1. So yung tinatawag natin ito na reciprocal. And that's it. So the next property is the distributive property for multiplication over addition of rational numbers. Let A over B C over D, and E over F be any rational numbers. Then A over B times the association of C over D plus E over F is also equal to A over B times C over D. Dinistribute lang natin yung A over B. Then plus A over B times E over F. Ang tawag natin doon ay distributive property. And that's it. The figure 9.1 shows how rational numbers are extensions of the fractions and the integers. So we have whole numbers, include or differences on the integers. Then going to rational numbers, include or permissible quotients. Ibig sabihin, ang sinabi natin permissible quotients, ang denominator ay not zero. Then yung whole number goes to fractions, include ang or permissible quotients. So whole number goes to fraction, ibig sabihin mga positive numbers lang ito. Then goes to rational numbers, include all differences. So lahat sila ay mag-meet sa tinatawag nating rational numbers. And that's it.